Hello guys, welcome back to Sapima tutorial. We want to continue our lesson on quadratic equation. Today we will be considering graphical solutions to quadratic equation. I will have a problem here on the board. I got it from past question 2013, even though I added some other questions under it. Alright, now the first thing we do is to produce our table using the relation given to us. We are given a table and we are asked to copy and complete. Okay, look at our relation. So the first thing we do is to produce a table on the answer script. That is always the first thing. It has its own mark. Don't solve and fill this table. Produce a new table where you will solve and put your information. Now we got all these numbers here from the range given to us, -3 to 4. That is where we got all the numbers, the range. All right, so the next thing we do is to solve for y. We will use this relation. Y is equal to 2, but some had already been given, so we'll put it here. We have here to be 35, we have here to be -7, -9, and 5. So we are going to solve for -2, -1, and then 2 and 4. So when my x is equal to -2, put it in this relation. I will have 3 into -2 raised to power 2 minus 5 into -2 minus 7. -2 squared is 4. 4 times 3 is 12. -5 times -2 is +10 minus 7. Now add here 22 minus 7, we have 15. So here is 15. Then we solve for when x is -1. The same process. I'll put -1 here, square minus 5 into -1 minus 7. Now -1 squared is 1 times 3, I will have 3. -5 times -1 is 5 minus 7. This plus this will give us 8. Minus here, I will have 1. So here my y is 1. We have produced that table. As soon as the table is produced, the next thing we do is go to B. We are given a scale to plot a graph with it. All right, so we have 2 cm to represent 1 unit on the x-axis and 5 units to represent 2 cm on the y-axis. So let's plot the graph. Now I've produced my Cartesian plane, the x-axis and the y-axis. Before I produce my Cartesian plane, I consider the values I have on my table. I have 35, positive 35 on the y-axis. So before I will draw the x Cartesian, I will make sure I have enough space up. Then for the x-axis, I have 4 to be positive. So I'll make sure that the space here will be enough to contain 4 before I will draw the y-axis. Then the next thing we consider is the scale given to us. I've written it here. 2 cm to represent 1 unit for the x-axis. That means for each 2 cm, from here to here is 2 cm, from here to here is 2 cm, because I am using 2 cm graph. So for each 2 cm, you write 1. We are using 1 unit. So our difference in range is 1. Then for here, we have 5 units to 2 cm. Okay. So for each 2 cm, you write 5. So I'll have 5, 10, 15, 20. Below is negative. The left-hand side of the graph is negative. Then the right here positive, up positive. So let's plot. When I have -3 for x, which is here, I will have 35 for y. Look at it here. The both of them will meet at this point. Make an asterisk there. If 35 is coming out and 3 is moving up, they will meet here. I have -2 and then I have 15. This is 15. Both of them will meet here. Next, I have -1 and 1. Now there is no 1 on the y-axis. How do I know the position of 1 on this graph? Divide the range by the number of little lines. That is how to get the numbers that are not on this line. My range is 5. I am using 5 units to represent 2 cm. Now the number of little lines, they are 10. If I divide here, I will have 0.5. That shows me that all the little lines are 0.5. So to get my 1, I'll start counting from 0. This 0.5, 1, all right? The second line is 1. I'll take it out, make an asterisk here. Then I have 0 against minus 7. 0, this is 0 for what? For x, and then minus 7 should be somewhere here. Recall that we have gotten the little lines on the y-axis as 0.5. So since I want to get my 7, I will say this is 5.56, 6.57. So my 7 is here, and I'm plotting it against 0. So it will be on the Cartesian plane. Then the next is 1 against minus 9. This is 1. Minus 9 should be close to 10. And I have 2 against negative 5. 2, here is 2. Negative 5 is here, so they'll meet here. Then I have 3 against 5, positive 5. This is 3, and this is my positive 5. They'll meet at this point. And then finally, I have 4 and 21. 4, this is my 4, and then 21 should be 2 lines above 20. The second line above 20, all right? So I've gotten all the points I need. The next thing I'll do is to join it. You either learn how to join by freehand sketch or your French curve, or you can equally use broom to join. For me personally, I normally use a freehand sketch. Now, while you are joining the points, make sure that your curve doesn't enter inside so much or come outside. Some people will draw it and it curves like this. It will give you a wrong value for everything you want to read on this line. And some will draw their own, it will go inside. It will give you wrong values. You must make sure you move from a point straight to another point, though you don't use a ruler to draw it. So we have been able to get a quadratic graph. Now the next question we have here says, from your graph, determine the roots of the quadratic equation. To determine the roots of quadratic equation, go to your curve and find where the curve touches the x-axis. This is my x-axis. The curve passed through the x-axis in 2 places, this position and this position, all right? So to get the roots of the equation, I'll take the value here. This is at -1. So x is equal to either -1 or at this point I have, let's get the value of this position. I have the difference between the numbers here, or my interval is 1, and I have 10 little lines here, so I'll divide by 10. If I divide here, I will have 0.1. So each little line here is 0.1. So I'll now count 2.1, 2.2, 2.3, 2.4. So I will have either -1 or 2.4. This is the root of this quadratic equation. You can decide to factorize this quadratic equation. You will get something in this range, very close to it, if not exactly. So the next question says, find the slope of the curve at x equal to 2. Anytime you have a curve, where you determine the slope must be given to you. You can't just pick the slope of any point. Now we have been told to determine the slope at x equal to 2. So we go to our x-axis, identify 2, draw a tangent to the curve at that point 2, this x-axis, and 2 is at this position. Now the axis we have under 2 is here. What we do is to draw a tangent that will touch this point. Having drawn the tangent, the next thing I'll do is to pick any 2 points on this tangent and trace it to the x and y axis so that I can get the values for x and y, which I will use to get the slope. Recall that the slope of a quadratic graph says y2 minus y1 over x2 minus x1. So to get the 2 points for x and y, I'll pick a point on this tangent. Let me pick here and here. You can pick at any position convenient for you. Now for this one, it will produce my x1 and y1, the point at the down. The one above will produce x2 and y2. To get my x and y, I'll trace to y-axis here. This is my y1, minus 10. Then trace this one up. This is my x, so I'll count 1.1, 1.2. Recall how we get the values of the little lines. So I've gotten my x1 as 1.2, and then y1 as minus 10 here and here. Then for x2 and y2, this point will be traced to y. Look at y here. If I trace it to y, it's at the origin, which is 0. And then x is already on the x-axis. This point is already on the x-axis. So I will have to count from here. 2.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7. It is on the 0.7. So I will have my x2 as 2.7 and my y2 as 0. So I'll put this information into this formula. All right, so y2 is 0 minus y1 is minus 10 all over x2 is 2.7 and then x1 is 1.2. Then we subtract, I will have positive 10. Minus times minus is positive. All over 2.7 minus 1.2 will give me 1.5. Then divide 10 by 1.5. We are going to be having 6.6666667, which I can approximate at 6.7. Right, 6.7 units. This becomes the slope of this graph. Then the next thing we are asked to find is the minimum or maximum. For this graph, it will have a minimum. To have a maximum from a quadratic graph, you have to produce a graph that is mountain-like. All right, the maximum is produced at the turning point. The maximum is produced at the turning point above. But if you have a valley-like curve, you are going to produce your minimum at the least, the turning points of the curve. So this is my turning point at this position. I will trace it to the y-axis. This is 5, 5.56, 6.57, 7.58, 8.59. So 9 is at this position, which is negative. All right. So my I is y equal to negative 9. Then the next thing we have here says solve the equation. We have another equation and it is a linear equation, and we are going to use the same scale for the quadratic curve to plot the straight line. So the next thing I'll do is to produce a table for it, choose values for x to get the values of y. So from the previous table or from the previous range, minus 3 to 4, I'll choose any 3 points of my choice. If I have 3 points, I'll be able to get a straight line graph. So I can take from minus 3, 0, and positive 3. All these numbers are in this range. All right. So I have y equal to 2x plus 4. I will solve. When x is minus 3, I'll put into this guy 2 into minus 3 plus 4. If I multiply here, minus 6 plus 4 will give me minus 2. So here will be minus 2. Then when x is equal to 0, I will have 2 into 0 plus 4. 2 times 0 is 0. 0 plus 4, this is 4. Then finally, when I have my x to be equal to 3, I will also put in the same function. 2 times 3 is 6. 6 plus 4 is 10. So here is 10. We'll now go to the graph and plot it exactly on the same Cartesian plane using the same scale. All right. So for x, we have negative 3. This is negative 3 for x, and we have minus 2 for y. Now minus 2 is at this position. Recall how we got minus 2. We'll not be going back to that. So we'll make our asterisks here. Then the next we have 0 against 4. 0 for x, 4 for y. 4 is at this position. Right? And then finally we have 3 for x. This is 3. And then we have 10. This is 10 at this position. Okay? So we join it with a ruler to make a straight line. All right, I've produced the curve. Don't forget to write the equation you solved on each of the lines. For this one, I have y to be equal to 3x squared minus 5x minus 7. So I've drawn this. Then the next question there says, find the intersection of the line with the curve. This is the straight line. The intersection is where the curve touches the straight line. So you discover that, look at this. It is touching here and it is touching here. So you trace it to the x-axis. Trace this one also to the x-axis. This is 1 at this point, but it's adjusted to the next little line if you observe well. So I'll count 1.1. This is negative 1.1. So that will be giving me x equal to negative 1.1, or we have here, this is 3.1.2.3.4 is on the fourth little line, and on the positive 3.4. So this is the intersection of the straight line and the curve. Sometimes you will be asked to find the roots of the equations. Talking about the two equations, you are asked to find the same thing. Just find the intersection of the curve with the straight line. That is the roots of the two equations.